Evaluate from 0 to pi over 4, cosine cubed 2x, sine of 2x dx. Okay? First slide here is substitution, because you see that cosine is sine is a derivative of cosine, cosine is a derivative of sine. So one of those two we're going to say u equals, and from there we're going to solve the problem. Now I know there's a negative involved, but we'll worry about that as the time comes. So what I'm going to say is u equals cosine of 2x. And the reason I chose cosine is because there's a 3 there and a 1 there. The 1 is the sine to the power of 1. And so it'll work out nicer if we say that we do u equals cosine of 2x. I don't have a good explanation for why it does, but you do it 3 or 4 times, you're like, oh, okay. So, I think the reason is but once we do the substitution, we'll be able to use the power rule for u, which will be cosine. So, power rule. I think that's it. Anyway, moving on. Du equals negative sine of 2x times 2. This is a chain rule, taking the derivative of the interior. Rearranging this, we get negative du over 2 equals sine of 2x dx. Get a different color to show what we're substituting here. Sine of 2x dx, sine of 2x dx. And we're left with integral u cubed, yes, u cubed times du, and we'll do negative 1/2. I'm good with that. So sine of 2x dx, negative du over 2, u cubed, yes. And then I left the limits of integration blank because I don't want to find those. Because my goal will be to go back to everything in terms of x. But we'll probably find them too, just to show that you can do it. Okay, so then u to the 4th over 4 times negative 1/2 equals u to the 4th over 8 negative, which equals, going back to u, we have cosine of 2x over 8 times, and then we go, now that we're back to x, we go back to our original limits of integration, but I'm going to reverse them to basically cancel out the negative sign that was right there. And from here then, we can actually solve the problem. So we have cosine of 2 times 0, which is 0. Is that 0? I think it's 0. 0 over 8 minus cosine of 2 times pi over 4, which is pi over 2 over 8. Get out our canceling colors. So cosine of pi over 2 is 0. So this whole thing goes to 0. So we're left with, this goes to 1. So we're left with an answer of 1/8. That's not too bad. Bring this over here. Yep, we have 1/8 right here. And so our answer will be 1/8. So now your question might be, well, what if instead of going back to x, we'd stayed with our substitution? If we had changed our limits of integration, which I usually try to avoid because things just get more complicated that way. Not more complicated, more, you get more gears in your watch. And it's good to have a nice, simple, streamlined mathematical process. So for me, it's easier not to change the limits of integration. But sometimes you'll come across a situation where maybe it is easier. So the idea of how to do this is I'm going to say you have x final. So I'm going to rewrite it this way. So this guy, that's going to be x final. That's going to be x initial. So if you have u initial, that'll be cosine of 2x initial, which we know is cosine of 2, x initial is 0, which equals cosine of 0 which equals 1. Okay? U final equals cosine of 2x final, just from our U substitution here, which is cosine of 2 times, I think it's pi over 4, which equals cosine of pi over 2, which equals 0. So when we change our limits of integration, we get 1 and 0. So this would be the same as negative u to the 4th over 8, where x initial is 1, x final is 0. Oh. And you can see we did pretty much the same calculations we did without changing the limits of integration. So u to the 4th over 8, there's supposed to be a negative sign in there, 0 to 1, then we have 1 over 8, 1 to the 4th over 8, minus, did I forget the 4th? Why did I forget the 4th? That is tragic. I messed up the first time, but luckily everything was 1, so it kind of worked out. Lucky, I got lucky there. 1 to the 4th minus 0 to the 4th over 8, which equals, again, 1 to the 8th, which was our answer. So, backtrack. We saw this was a substitution problem. We saw we had a cosine cubed. We had a sine that was to the first power. We're like, okay, we're going to take the u equals the cosine, get the derivative of sine, do some canceling, substitute in the dx, plug everything in, make sure we have our limits of integration correct, plug in the numbers, and we get a final answer. Don't forget to do the power to the 4th like I did. Luckily it turned out to be 1, so it was fine, but you shouldn't live your life that way. So 1/8 is the answer, and then problem solved. So hope this helped you out. Hope this helped illustrate how you do trigonometric substitutions, at least pretty simple basic ones. And I will see you guys on the next